Okay, let's explore chapter 6, which is called Polynomial Functions. And section 6.1 is exploring the graphs of polynomial functions. What is a polynomial function? You use these in grade 9 if you remember, and a bit in grade 10, or you could just go to page 382 in your textbook and copy this into your learning journal. So a polynomial function is one variable is a function that contains only the operations of multiplication and addition with real number coefficients, whole number exponents, and two variables. Okay? So real number coefficients, so coefficients are the big number in front, whole number exponents, and two variables which are x and y. The degree of the function is the greatest exponent of the function. So for example, f of x, that's how you say that, is equal to 6x to the power of 3 plus 3x squared minus 4x plus 9. It's a cubic polynomial function because it has a function of 3 degree. 3 degree comes from the highest order or highest number exponent. The degree of a polynomial function also determines the shape of that function. So things that you need to know. Okay, so the graph of a polynomial function of the same degree has common characteristics. The chart below shows sample sketches of functions and displays all the possibilities for the x-intercepts, y-intercepts, and behavior, range, and number of turning points of each function. So for example, if you look down the first column where it's a constant, it has a degree of 0. This is a graph where y is equal to 4 or y is equal to negative 4. So there's actually no x variable in this graph. Okay, so there'd be 0 except if y was equal to 0. And number of y-intercepts would be 1 because it just crosses the y-intercept at one point on the graph. End behavior means where it extends from and where it ends up. So if you remember your quadrants, it goes around in counterclockwise. So quadrant 1 is always here, 2, 3, and 4. So your end behavior is always based on what quadrant it starts in and what quadrant it ends in. So the line extends from quadrant 2 to quadrant 1 if it's a positive, and it extends from quadrant 3 to quadrant 4 if it's a negative value. Okay, so your domain is x as an element of the real numbers, so any x and any y, or if it's a constant, y can only equal the constant, but it can be any element of the real. So you could have a fraction or a decimal. And number of turning points for this one is 0. If you look at a linear function, you see that it has a degree of 1. So it has at least, well, it has only 1x with no power. Okay? The graph is a straight line. It can go up, down, either or. It only has one x-intercept, meaning it crosses the x-axis only at one point. It has one y-intercept, which it crosses the y-intercept only at one point. Its end behavior depends on if it's a negative or a positive x, so that's your coefficient in front. So if it extends from quadrant 3 to quadrant 1, it's increasing, so it's a positive x. And if it's going from quadrant 2 down to quadrant 4, it's decreasing. That would mean a negative x. So the domain and the range are both element of reals, and it doesn't turn. It just goes in a straight line. For a quadratic function, you've seen a quadratic last year. We went through this. It's the parabola or the curve graph, and that is an x squared is your highest power in this example. Okay, so you can have many different shapes, or pardon me, there are many different areas of the graph, but the shape is always a parabola. Okay, so number of x-intercepts could be 0, 1, or 2. It depends how many times it crosses the graph. This green one here has 0 x-intercepts, the red one has 1, and the blue one has 2. Okay, number of y-intercepts is always 1, so it only crosses the y-axis at one point. Okay, the arrows tell you it goes on forever. So end behavior, it depends. Either the curve extends from quadrant 2 to quadrant 1, or from quadrant 3 to quadrant 4. The domain is always x as the element of the reals, for all of them if you notice that. And y is always your maximum or your minimum value. Depends if the graph is up, or open down. And you know what max and min are from last year. Okay, and it has one turning point, meaning that at some point at the graph, so the blue one goes down, 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 it hits its minimum, and it turns, and then it starts going up, 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 up. Okay, that's what a turning point is. For your cubic function, you have x to the third degree, so x cubed, at least one of your x's have to be cubed. And this graph displays a behavior that's, I don't even know how to describe it. Can't think of it right now. So number of x-intercepts could be 1, 2, or 3. Just like your quadratic, it's going to cross at different points on your axes depending on what the graph's equation is. Okay, it's only going to have one y-intercept, which is the same throughout the 4. And the curve extends from quadrant 3 to quadrant 1, or from quadrant 2 to quadrant 4. So quadrant 1 and quadrant 3 are always paired, and quadrant 2 and quadrant 4 are always paired in this one. Okay, that's important for when you're answering questions. Element of the reals, and 0 or 2 turning points. It cannot have one turning point. So either it goes down, 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 stops at turning point, goes up for a bit, it turns again and continues to go down. Or this one, it goes up, turns a bit, goes not flat, and then it goes up again. Okay? So if we go back to the first page on the section, which is on page 380, I didn't tell you that, there's just some important terms that you need to know for this first section. So end behavior is describing the description of the shape of the graph from left to right on a coordinate plane. So you're always going from left to right on the coordinate plane. So for example, this end behavior of this one starts in quadrant 3 and extends all the way to quadrant 1. And this is a linear function because x has to the power of 1. Okay, for example, this one, x is to the power of 1 as well, and you go from quadrant 2 down to quadrant 4. Cubic function, a polynomial function with the third degree whose greatest exponent is 3. So if you see a polynomial function with a x cubed, you know this is a cubic function, and we just talked about what those graphs look like. Okay, so from this section you have to be able to explain number of x-intercepts, y-intercept, and behavior, domain, and range. And we'll get to turning points. Okay, so if I go to the next part, here we see turning point. So any point where the graph of a function changes from increasing to decreasing, or from decreasing to increasing. For example, I have the cubic function down here. I'm going down, 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 down. At the turning point, it changes direction and goes up in the opposite direction. It has another turning point, and then it continues back down. And that's pretty much what you need to know from this section. So please make sure that this whole thing is copied out into your learning journal. It's very important to use on the final exam so you don't have to remember stuff like that. And your questions should be on page 383. I would do questions 1 and 3. It's just explaining the things we just talked about of different polynomials you're given.